Hello, everyone, and welcome to part 2 of derivatives of exponential and logarithmic functions. We've been doing a lot of derivatives, and I think we're at the point where you can probably read this formula and go ahead and do these problems on your own. So I've already written the answers if you want to just quick screenshot it and then stop the video. I am, of course, going to do them now, but I think you'll be able to get most of these on your own just by following the formula. But here we go. The derivative of the natural log of u is just 1 over u times the derivative of u. So y prime, this is going to be my u, always identify your u, is going to be 1 over 5x times the derivative of u, which is just 5. So remember, when you're trying to multiply a fraction by a whole number, you can make them both fractions so that you can do numerator times numerator and denominator times denominator, and you get 1 over x. Number 2, again, start by identifying your u. U is cosine of x. So the derivative of the natural log of u is 1 over u times the derivative of u, which is negative sine of x. Again, if you're multiplying a fraction by a whole number, you can change it to a fraction times a fraction, numerator times numerator, and denominator times denominator. And of course, this can be simplified to negative tangent of x. Number 3 looks tricky. Just keep your pattern. This is u. So the derivative of a natural log is 1 over u times the derivative of u. So what's the derivative of ln of x? It's 1 over x times the derivative of x, but fortunately that's just 1. So we get 1 over x ln of x. Are you liking these? I hope so. So now we're going to start adding some new things. We're going to add our power rule. When you have something raised to a power, you're going to bring down the 2, and then you rewrite natural log of x to the first power times the derivative of the inside. And what's the derivative of the ln of x? 1 over x. So this is in terms of u, but just if you want a more simplified version, if you just have ln of x, then the derivative is just 1 over x because it's times 1, but you don't need to write that. So this is your basic formula. I can rewrite this a little simpler, put this over 1 and this over 1, and then you have numerator times numerator over the denominators being multiplied. These x's don't cancel. This top x is stuck to the ln, so don't cross those off. Again, identify your u. So the derivative of the natural log of u is 1 over u times the derivative of u, which is 2x plus 2. Numerator times numerator, denominator times denominator. Number 6. Hopefully you see it. It's a product rule. Really easy to forget to use the product rule. The second times the derivative of the first. The derivative of e to the x is just e to the x. We learned that in part 1 of this video. Plus the first times the derivative of the second. And the derivative of ln of x is just 1 over x. Oftentimes you'll see these answers with the e to the x factored out, which would leave you with ln of x plus 1 over x. This answer has them reversed, but by the commutative property, that's okay. I did squeeze the answer to 7 on there in case you were working all the way through, but for me, it's on the next page. So this one is a little bit harder. You could do, oh, you do not want to do this. If you do this as this is your u, and then you do 1 over e to the x over 1 plus e to the x, and now you do the derivative of u, you're going to need quotient rule. This is awful. You really are going to want to expand it first. So instead, rewrite this as y is equal to L. Sometimes the pen does that. Y is equal to ln of e to the x minus ln of 1 plus e to the x. Do you remember that? The natural log of a over b is the natural log of a minus the natural log of b. Always look for ways to simplify whenever you can. And even before I keep going, the natural log of e to the x is just x. Now, I can't do that here because you've got that 1 plus stuck in there. But now we can do the derivative easily. The derivative of x is 1. And for this one, this is going to be my u. So the derivative of ln of u is 1 over u times the derivative of u. And the derivative of u is going to be 0 for the 1. And then the derivative of e to the x is just e to the x. Again, you're going to want to simplify that to a single fraction. So the numerator times the numerator and the denominator times the denominator. There we go. Okay, so number 8 is not an especially hard question. It says find the derivative. The derivative would just be, if this is going to be your u, 1 over x minus 3 times the derivative of u, which is just 1. It is literally just 1 over x minus 3. Here's the tricky part. It says state the domain of f prime. And most people would write x is not equal to 3. But that would be wrong. Okay? You must always consider the original function. You can't take the natural log of a negative number. You can't take the log or the natural log of a negative number. And it's much easier to see graphically. So f of x is the natural log of x minus 3. So a general natural log graph would be here at 1, and it would look like that. Our graph, x minus 3, is actually going to move 3, 1, 2, 3 to the right, and it's going to have its asymptote at 3. It's going to look like this. That's our graph. So for a derivative, you definitely can't find the derivative at 3 because there's an asymptote there. But you can't even find the derivative at any number less than 3. So the domain is going to be x is greater than 3. Even though after you've taken the derivative, it looks like it's just x is not equal to 3, it's actually x has to be greater than 3 for your domain. So for number 9, this is another one of those tangent ones. We've been doing them in every section of notes. It says a line with slope m passes through the origin and is tangent to the graph of y is equal to ln of x. All right, let's try and draw that. So here's my basic graph. So I'm going to make my natural log green. Natural log, really the only thing you need to know is where its asymptote is, its general shape, follows the y-axis, and then it kind of goes out like that. That's y is equal to ln of x. And now I'm going to graph a line that has slope m, and it passes through the origin. And it's going to be tangent to this graph. Just barely going to touch it like that. So since it passes through the origin, I know its slope, and I know a point, which I can rewrite this as y is equal to mx. So I have a red line and a green curve. Whenever you're doing one of these problems, it's always going to be about creating a system of equations that has to do with two things. We want an equation that has to do with the point, and then we needed equations that have to do with the slope. So let's do the point first because it's easier. So this point right here is on the line and it's on the curve. On the line, this point, if you knew x, how would you get y? Mx. If it's on the curve and you knew x, how would you get y? Ln of x. So we know from this that mx is equal to Ln of x. That's our first equation. We need two, since we have two unknowns, m and x, we need two equations. So the second thing that we know is that for the red line, the slope is m at every point. It's constant. So there's no formula for the slope, it's just constantly m. For the green curve, we know that there's a formula for the slope. And the slope at any point on this curve is 1 over x, because that's the derivative of ln of x. So now I have a second equation. M from the line is equal to 1 over x. So now I can put these two things together. I substitute m is equal to 1 over x where I see the m. So I write 1 over x, that's where the m used to be, times x is equal to ln of x. I get 1 is equal to ln of x. Do you remember how to get rid of an ln? E both sides. So I'm going to rewrite this as e to the 1 is equal to e to the ln of x, because an e and an ln are inverses of each other, so they cancel each other out. So my question was, what is the value of m, not e? So I'm almost done. I'm right there. So I just go back and I can substitute in either one, but this one's easier. So m is 1 over e. Very tricky problem in my opinion, especially because they use the letter m. I almost changed it, but you need to learn to use the tricky letters. So just like we learned that y is equal to e to the x, the derivative was e to the x, and then we moved on to y is equal to a to the x, and we had the derivative was a to the x times the natural log of a. Hopefully you remember that. Now for logs, the derivative of log base a of u is pretty much 1 over u, just like before, but you have to add that ln of a. And it's easy to remember that it goes on the bottom because the u is on the bottom, so it's right there. So I will take just a minute here and write down these couple of answers for you. Y prime is equal to 1 over 2x, in case you decide to try this on your own. Y prime is equal to negative 1 over x, ln of 2 log base 2 of x squared. Y prime is equal to 1 over 1 plus x, ln of 3. And number 4, since it didn't fit, is y prime is equal to cosine of x. So if you want to screenshot those answers and try them on your own, but I am going to do them together. So number 1, first of all, always simplify. If you got this one wrong and you don't know why, you probably didn't simplify first. So even though it says y is equal to log base 5 of x to the 1/2, I would move that 1/2 out in front. 1/2 log base 5 of x. And it's going to be so much easier if my u is now just x. Because when you take the derivative of u, it's going to be 1. Here, the u is x to the 1/2. du is going to be awful, right? So always want to simplify u if possible, which with logs is something you can do. And then now we just obey the formula. The 1/2 is a constant. I'm just going to leave that alone. And according to this formula, log base a of u is 1 over u, natural log of a, natural log of 5, times the derivative of u, which is just 1. I should simplify just a little bit. Numerator times numerator, and denominator times denominator. So this one you have to decide if you're going to use quotient rule, or you could bring it to the top and call it log base 2 of x to the negative 1. So you've kind of got some choices there. I actually think I'm going to do it this way. So my y prime will be negative 1 log base 2 of x to the negative 2 times the derivative of the inside. So the derivative of log base 2 of x, using this formula up here, is 1 over u. So my u is just x. 1 over u, natural log of a, so the base is what they're talking about, so natural log of 2, times the derivative of u, which is just 1. So going across the top, this is a numerator and the 1 is a numerator, but that's it. This moves to the bottom because it has a negative exponent. Now it's positive. And then that's on the bottom, x natural log of 2. Number 3, using the formula. There's nothing to do here. Every once in a while, somebody thinks they can do something. They're like, oh, hold on with a plus. Can't you expand it? You can't. It's only if it's multiplication, you can expand it to addition. But if it's addition like this, there's nothing you can do. So the derivative is just going to be, this is my u, 1 over u times the natural log of a, there's my a, times the derivative of u. So let's put this off to the side. U is 1 plus x natural log of 3. du is 0 plus, and a lot of people get this wrong, the natural log of 3 is a constant. This is the same as natural log of 3 times x, but people don't write that because it would look like natural log of 3x. So they put the natural log of 3 on the back side, but this is the same as like x5 or x4. I mean, it's not to the 5th. It's literally just a number with x. So its derivative is literally going to be natural log of 3. So times the natural log of 3. And I just realized I wrote natural log of a there. That should be a 3. So now if I make this into a fraction, I have a natural log of 3 on the top and a natural log of 3 on the bottom. They cancel. And so my answer is just 1 over 1 plus x natural log of 3. Number 4. So possibly some of you tried this on your own, really struggled through. Don't be sad, but there's a really easy way to do it. Not y prime yet, just y. You can simplify. A log base a with an exponent base a just cancels. This is literally just this. So the derivative is just cosine of x. Don't be mad at me. Okay, so I kind of showed this to you on this one where we took that 1/2 and we moved it out front, but I really want to focus on that. We can use properties of logarithms to simplify the differentiation process. This is going to make such a difference in your world to remember this. So again, if you would like to try these in advance, I will put all the answers up here. Number 1 was y prime is equal to 3 over 2x. Number 2 is y prime is equal to negative 1/3 tangent of x. Number 3, y prime is equal to 2x squared plus 1 over x times x squared plus 1. And number 4, y prime is equal to 1 over 1 minus x squared. So if you'd like to screenshot those 4 answers, then you might not have to watch all of the video. All right, let's do them out. So when you see this, whenever you see natural log, you always have to be thinking, can I simplify? And you can. That 3/2 just goes right out front. Natural log of x. It's a constant, so you can just leave it there. The derivative of ln of x is just 1 over x. So your final answer is 3 over 2x. How awesome is that? Now, I have to take just a minute and show you how terrible this problem would be if you forgot. So if you're being miserable, this could be why. If you did the derivative right away, where y was equal to ln of x to the 3/2, and this was your u, you would have to do 1 over x to the 3/2 times the derivative of u, which is 3/2 x to the 3/2 minus 1 is 1/2. And then you would have to realize that this 3 and this x to the 1/2 are in the numerator. This x to the 3/2 is in the denominator, but so is this 2. And then if you have x to the 1/2 on top and x to the 3/2 on the bottom, you would have to algebraically correctly get that there is 1 left on the bottom. That is so much harder. You do not want to do that. So this simplification is something worth really learning. How do we do it in number 2? Well, this is equal to the natural log of cosine of x to the 1/3. That 1/3 can come out in front. And now it's just a constant. So y prime, remember this is still y. Y prime, the constant is still just there. This is my u. The derivative of the natural log is 1 over u times the derivative of u. Remember that when you're multiplying a fraction by a whole number, you can put it over 1. I know some of you are like, if she says that one more time, but some people need to keep hearing it. Gives me negative tangent, and the 3 stays on the bottom. Or if you don't like it that way, you can write 1/3 tangent of x. These two are the same. People struggle to recognize that, but they are the same. Okay, let's take it up a notch. Using expanding from pre-calculus, this becomes the natural log of x plus the natural log of the square root of x squared plus 1. And then this becomes the natural log of x plus the natural log of x squared plus 1 to the 1/2. And now that it's a fraction, an exponent, I can bring it to the front, not of this one, just of this one, 1/2 natural log of x squared plus 1. Now, lots of you can get from here to here without showing all the work. That's fine. But you should definitely expand that first. So now, notice I kept labeling it y, because now I'm going to do y prime. Surprising number of people forget to do y prime because they feel like they've already worked so hard. Y prime, the derivative of the natural log of x is 1 over x. The derivative of the next part that's a constant. This is going to be my u. So the derivative of the natural log of u is 1 over u times the derivative of u. So I get 1 over x plus, I'm going to put this over 1. Multiplying across the top, I get 2x. And multiplying across the bottom, I get x squared, and 2, x squared plus 1. And the 2's cancel. So there's really nothing bad about this answer, except you might look at it and then you look at the answer key and say, oh, I got it wrong. Not necessarily. You have to be willing in calculus to say, maybe my answer is right and it's just not what they have. So try changing it. Give it a common denominator. You can do it. That gives me x squared plus 1 plus x squared all over x times x squared plus 1, which gives me y prime is equal to 2x squared plus 1 over x times x squared plus 1. And that was the answer. Okay, last one in this section. Again, I'm going to expand. The thing that makes this one tricky is not the expansion. Most people have got this down by now. Anybody see the mistake? Come on, look, look, look. Parentheses. That 1/2 affects the entire thing. And without it, it would be incorrect. Believe it or not, I'm already ready to go. That was really the only thing I wanted to point out on this problem. There's no other way to expand it. So this is my u. So the derivative of the natural log of u is 1 over u times the derivative of u. Now this is my u. The derivative of the natural log of u is 1 over u times the derivative of u. This can be simplified. So I get 1 over 1 plus x. Now be careful, that -1 only affects the numerator, not the numerator and the denominator, or it would just cancel itself out. But this minus and this minus cancel. And so I get that. Look how much tidier the actual answer is. So let's keep going. And I realize I'm showing every last little step. You can probably do some of these in your head. 1 plus x, 1 plus x. This one needs the 1 minus x and the 1 minus x. And that gives me 1 plus x plus, oh, that's 1 minus. Just wrote it too close together. 1 minus x plus 1 plus x over, and if you FOIL that out, you'll get 1 minus x squared. Y prime is equal to, this numerator just becomes 2 over 1 minus x squared, which is how they ended up with something so nice and tidy for an answer. Okay? All right, so this is the end of part 2 of the derivatives of logarithm and exponential functions. There is a part 3, but yay you, Honors Calc, you get to take 3 days to do this. So this is the end of part 2. I'll catch up with you during part 3.